So hello and welcome to our couch lessons. My name is Jeanette and I'm working for the Goethe-Institut, and right now I'm sitting not on a couch but on a quite comfortable chair here at the headquarters in Munich. And I hope you have made yourself quite comfortable, maybe on a couch, maybe with a cold drink in your hand. And I hope that you enjoyed the music. It was composed by a Berlin-based artist, Holly Herndon, and she works with artificial intelligence to create her music. So I thought it would maybe a nice intro into our first couch lesson. I'm very happy that you take part in our new format and that you want to learn more artificial intelligence. AI will contribute to a new revolution in human history. That is what you can read over and over again. And we want to question what that means for society, for our society, on different levels and also in various fields. And with we, I mean Martin and myself. Martin is my co-host, and maybe you want to introduce yourself briefly, Martin.
Hello, everybody. My name is Martin. I'm a curator and context maker based in Malmö, Sweden, and you will hear more from me shortly.
Thank you. The couch lessons are organized by the Goethe-Institut, the worldwide active cultural institute of the Federal Republic of Germany. We promote the study of German language on the one hand, and on the other hand, we want to engage in international cultural exchange. With the couch lessons sponsored by the Federal Foreign Office, we want to sensitize our listeners to the new developments in the field of AI. We want to encourage them to engage in a discussion that is not only taking place in a technology-savvy community, and we want to motivate them to think and to ask questions. We also want to move a dialogue beyond the national borders. This is more important than ever, especially in times of the Corona crisis, and with it in times of an increasing tendency to nationalism and to isolation. So before I hand over to Martin, my co-host from Sweden, I would like to inform you briefly about some guidelines of the couch lessons. So first, all the experts will give an input, each about 10 minutes long. And after the inputs, they will have a discussion with Martin. During the whole time, you can ask questions or you can contribute your opinions, your thoughts in our chat. And if you have technical questions, please write to my colleague Sabine directly. Sabine, maybe you want to say hello?
Hi, my name is Sabine. I'm also from the Goethe-Institut, and I'm responsible for the technical part today.
Thank you, Sabine. And I also want to introduce my colleague Brigitte. Can you also say hello?
Hello, my name is Brigitte. I'm also working here at the Goethe-Institut, and I'm very excited to be part of the first couch lesson.
So me and Brigitte will go through the chat, and we will pick out some questions that will be discussed after the 45 minutes of the couch lessons. Then we will unmute all the microphones and we will ask different persons to contribute their questions personally. But if you are not asking, please don't unmute your microphone. I also want you to know that the whole session is recorded, but we will just record the persons that are speaking. You can always turn off your video, you can turn off your microphone, but we will invite you to keep on your video so that we can see each other, and for that I would recommend to use the gallery view. I think that's enough from my side, and I want to hand over to Martin. Thank you for listening.
Thank you, Jeanette. And gosh, what a different spring this is. For me personally, one of the things I'm learning is what a struggle it is to schedule things to look forward to. And online lessons like the one we're embarking on today has really been a lifesaver for me. And it's been an honor to give you all the reason to gather for an hour together. And although we're all alone by our computers, there is no reason to feel lonely in this moment. And let's also acknowledge the fact that, and really take a moment to celebrate that people from all around the world are in this call. It's easy to take for granted, but I think it's quite beautiful that you are here today, that you found out about this, that you decided to sign up and actually also showed up. So thank you very much for that, and congratulations to us. And it's of course exciting and very timely to kick off this series of online lessons that we've planned with a session on how artificial intelligence is utilized to fight COVID-19. More than 320,000 people has died from the disease already, and many believe that we're still in the very early phase of this. But just like with all major challenges that humanity is facing right now, and I really try to keep climate change in mind still, although this pandemic is going, a lot of hope is put to coming technological advancements. But still the concentration of greenhouse gases in the atmosphere is growing. And the most frequently recommended technology to slow the pandemic is more than 2,800-year-old invention. We call it soap in everyday language. So I think that's quite fascinating how technologies old and new can collaborate. But for this session in particular, we're going to look into how artificial intelligence can potentially fight the novel coronavirus and the COVID-19 disease. With us, we have three experts that brings different perspectives. We have Karen Howe from Boston, we have Björn Schuller from Munich, and we have Raul Panicker from Mumbai. And they will all have 10 minutes to present, like Janet said. And at the very end, we have time for questions and answer from the audience, from you guys. But now I want to introduce you to our first speaker. Her name is Karen Howe. She's a senior AI reporter at the MIT Technology Review. There she writes articles that aim to demystify the field's latest news and research. For us, she'll give an overview of the different ways in which AI is used to fight the coronavirus. Karen, it's a pleasure to have you in all the way from Boston, USA. Please share your screen, feel the love and energy beam from 128 participants that now is going to make their most creative couch moves to applaud you. Karen, the microphone and screen is yours.
Thank you so much. Thank you, Martin, and thank you, Jeanette, and the Goethe-Institut for hosting this. As Martin mentioned, I am the senior artificial intelligence reporter at MIT Technology Review, so I spend my days covering a lot of the emerging research that comes out of the labs. And I was asked to give a 10-minute talk, really emphasizing the 10 minutes of all of the different ways that AI is currently fighting COVID, which is a pretty tall order because there are a lot of different things that are happening. So I'm going to try and go through this as quickly but as clearly as possible. So the first thing that I wanted to start with, for people that might not necessarily be familiar with what AI is, I think AI can often be construed as like this magical thing that you can just apply to things. So I'm just going to do like a 30-second to 1-minute introduction on what AI is. So for the purpose of this talk, we can think of AI as a collection of computational methods that receive input and then use that input to autonomously make a decision. And if that doesn't make sense, here's a diagram of how I think about it. You have your input, you have the computation, you have the output, and most often the input is a ton of data. The computation is basically some method of fancy statistics that's happening, and then the output is the decision that you're making. So some common AI systems that we use today include face recognition. So the input might be all of the photos that you upload to Facebook and then tag. And then the AI algorithm takes all of those photos, learns it, and then it can suggest tags of your friends in the newly uploaded photos. Another system is recommendation systems. If the input might be the movies that you're watching on Netflix. Those are all fed into an AI algorithm, and then they output movies that you might also enjoy. And then another common system is autocomplete. When you're writing on Gmail or if you're texting, those are different autocomplete systems that are predicting based on all of the emails that you've ever written, what words you might likely type next. And so now that we have this kind of basic understanding of AI, we can think about the ways that it's applied to the pandemic. If we think about the timeline of the pandemic from the very beginning of when it started to how it's going to continue on, you can divide that into kind of different phases: detection, containment, testing, treatment, vaccination. And each of these phases have different ways that AI is being applied in them. And there's also ways that AI is being applied across these phases. So I'm going to go through each of these and kind of quickly give you a taster of some of the projects that are happening in each of these categories. So the first thing that I wanted to talk about is detection. And I think many of you have probably read headlines at this point that said that the story goes that it was an AI system that was the first one to flag the fact that there was this novel pneumonia outbreak in Wuhan, China. And that was a system called HealthMap that is maintained by the Boston Children's Hospital. And essentially what it was looking for is, it was looking at social media feeds and news articles and the chatter, and it discovered that there was kind of this anomalous chatter that was happening, and an AI system then flagged and sent an alert out. There's actually a number of systems that did this early on. Here are three, so HealthMap, Blue Dot, and MetaBiota, and all of them kind of use a similar process. And so if we apply the AI framework that we have, the input is often social media posts, it's news articles, it might be flight patterns, and it's looking, the AI algorithm is looking for anomalous behavior because it understands what normal behavior is. And once it detects that anomalous behavior, it then sends an alert saying there might be a disease outbreak. What's interesting about these systems, the pro is that they're definitely speedy. But the con is that they're not necessarily that speedy, in that only 30 minutes after the HealthMap flagged a disease outbreak, a human team then sent out a report because they had actually been working hours in advance based on email exchanges that had been happening across the globe about this novel outbreak that was happening. I think the other limitation of these systems is when the HealthMap organization flagged it, they actually rated the disease outbreak as 3 out of 5 in terms of level of severity. And so what this demonstrates is even though it can be a speedy mechanism, you really do need the human experts that are trying to understand whether or not this is actually something of concern. So there was this really great AP article that I was reading that had this analogy saying these systems are kind of like car alarm systems right now, in that they're very easily triggered, but you really need the human to verify whether or not someone's actually trying to break into your car. So the next phase is containment, and there's 2 different common ways that AI is being applied. The first is planning. And so with planning, what's happening is there are a lot of different models that are being built right now by various different research organizations to try and predict the trajectory and spread of the virus. And this is an article from 538 that really nicely shows some of the more common and more reliable models that are out there right now. Not all of these models use machine learning, but I did want to highlight one of them that does. And this is a group that I wrote about in an article of mine. This is the Delphi group at Carnegie Mellon University. They're one of the best flu forecasting labs in the United States. And when the outbreak happened, the CDC in the US basically tapped this group to try and repurpose their flu forecasting methods to forecasting the coronavirus. They use multiple different types of machine learning techniques. So what they're doing is they're essentially looking at various inputs like the reported cases, drug purchasing behaviors, search queries, and a multitude of other things through partner organizations. They partner with Wikipedia, with Google, with the CDC. And then they try to analyze based on those different behaviors, first, how many cases there might be right now, and second, how many cases are coming, how much is the case volume going to grow over time. And this can be helpful for policymakers to try and understand and prepare resources, and also send testing kits to the right areas, prepare more hospital beds in different areas based on these tools. But I think one of the limitations, again, of this tool, you can just notice it from this 538 article, is that these models don't always agree. And that's because they are all using different input data, and they all have different methods of trying to predict. And so we have some level of confidence that perhaps they're showing us the right trajectory, but it's not like a be-all, end-all prediction. And actually, the head of the Carnegie Mellon University lab, he personally told me that when he was tapped to forecast the coronavirus, one of his greatest concerns is that AI is really great when there are known patterns of behavior, when there's lots and lots of historical data from it to learn from. It's not great at all when there are suddenly novel patterns of behavior. So he himself was a little skeptical that the techniques that they developed for flu forecasting, which is a very well-known disease and has over 20 years of historical data, could actually be successfully applied to the pandemic, which is every pandemic has completely different characteristics. So this is the first time that we're really seeing these patterns of behavior. So that is planning. The other part of containment is surveillance, and I just want to quickly play this video. So this was a system that was released by a company called Landing AI that was founded by Andrew Ng, who is a pretty big hotshot in the AI community. And as you can see, this system is basically trying to figure out where people are within a video and then decide whether or not they're properly social distancing. And so going back to this framework, this is how it's kind of looking at how the system works. And this system, in the video, it's a little misleading because it's showing the system being used in a public space, but in actuality, the system was developed for factory floors. And the pro of the system is that, in theory, this is a way that you can help reopen factory floors or reopen other places that give essential services to people and maintain safety. But one of the huge cons is that this is also pretty intensely privacy violating, and it doesn't necessarily work. You can tell people that they are too close, but how do you actually alert them that they need to move apart? And it kind of plays into some of the power imbalances that already exist between corporations and their workers. So this example kind of demonstrates a point that I want to hammer, which is AI can be applied to many things, but it doesn't necessarily always mean that it should be. So the next phase is testing, and there's a lot of assistive diagnosis tools that are coming out. And this is an article that I wrote a couple weeks ago about how doctors are now using AI to triage COVID-19 patients. One of the most common triage tools that's currently being used in early research, doctors found that the COVID virus manifests as pneumonia, viral pneumonia, in a lot of different patients, particularly severe patients. And that has telltale signs in a lung scan. And so what they're doing in this instance is they're collecting lung scans of healthy patients and of COVID patients, and then using the AI algorithm to learn the different patterns of what they should be looking for in a lung scan to detect whether or not a patient actually has COVID. This system is pretty common now. There are many different variations. There are a lot of companies that are developing this, and it's being used in Spain, in France, in Brazil, in South Korea, in the UK by the NHS. And one of the pros, I suppose you could say, is that it can help supplement doctors, because doctors might have a lot of patients that they're trying to handle. And the system, one of the benefits of AI is it doesn't get tired. So it can look at a lot of patients and always consistently give use the same framework for decision making. But one of the cons is also that if it makes an error, this is a life-death situation. So one of the really important parts of these tools, the reason why I call it assistive diagnosis, is because they are not the ones making the final call on whether a patient has the disease, but they can supplement the doctors and the radiologists to kind of double check their work, and vice versa. Another diagnostic tool that Raul and Bjorn will be talking about is related to cough detection and whether or not the cough the sound of your cough might indicate that you have COVID, and I will skip over this to let them dive deeper into that. So with these systems, once again, the input is the symptoms and the signs of the disease, and the output is a prediction on whether or not the patient has COVID-19. So the next three phases that I want to talk about, scientific research, treatment, and vaccination, are the ones that I'm personally most excited about. Scientific research, there's this amazing project that has come out recently in, I think, the last couple months, which was a collaboration between the White House, the NIH, and AI research organization called Allen Institute for Artificial Intelligence, the Chan Zuckerberg Initiative, and all of these different organizations came together to compile a giant database of the latest research on COVID-19, but not just PDFs, but specifically machine readable papers, so ones that can easily be fed into algorithms to then analyze and understand. And so what this project was hoping to facilitate is the acceleration of scientific research in understanding the nature of COVID-19. The input is the research papers, and the output might be things like, here are all the different related papers to a question that you're trying to answer. Or here are papers that disagree, so that we might need to do more studies to figure out what the actual scientific consensus is. Or here's some distilled findings on the particular component of the virus and its behavior that you're trying to look at. And so this scientific research is kind of like undergirding the drug discovery and vaccine development work that's now happening as well. So with drug discovery, I wanted to highlight a case study from a company called Benevolent AI. They're a UK-based startup that is basically trying to develop an end-to-end drug discovery platform. And they recently put out this paper where they use their platform to kind of identify possible COVID-19 drug. And so what they're actually doing is they have their AI algorithm and they're feeding it information about the proteins that the virus latches onto on our cells, which is how the virus gets into our cells and then can disrupt our immune system. And it's feeding it in existing drugs. One of the challenges of drug discovery is that it takes a notoriously long time. And so one of the best ways to speed up the discovery of drugs for COVID-19 is to actually just look at drugs that have already been approved for other diseases that might actually have the effects that we're looking for in treating COVID-19. And so they put those inputs in and they identified which drugs block those proteins. And this is a diagram from their paper where they identified actually 4 different drug candidates that are here in the bottom, which I cannot pronounce the names of. But one thing that they looked at afterwards, the algorithm then tried to analyze what level of dosage would you need for each of these drugs to actually ameliorate some of the symptoms, some of the life-threatening symptoms of COVID-19. And in the end, they identified this drug, which is a drug for rheumatoid arthritis, that might be a possible candidate. And so through this process, which usually takes weeks, months, maybe even years, they were actually able to do this in just a few days. And this drug is now being tested in a clinical trial. And there are over 400 other drugs that are also 400 other clinical trials that are also testing various other drugs to try and accelerate this process. So the last one is vaccine development. And here's another paper that I wanted to highlight from 2 researchers at Stanford, where essentially they were looking at, in vaccine development, one of the ways that you can develop a vaccine is to identify the parts of the virus that will trigger a really great immune system response to help your immune system familiarize itself with the virus. And so it kind of looks, they need to find 2 different features. One is the the viral component is something that antibodies can actually target. And the second one is the viral component is something that would actually surface on your cells so that your immune system can recognize the infected cells and then kill them off. And so in this paper, they basically used AI techniques to scan all of the different viral components that are currently known for COVID-19 and identify them for these two features. And from that, they found that specifically there's this thing called spike proteins on the virus that seem to exhibit these features. And now that's one of the things that a number of different research groups are now trying to use to develop into a vaccine and then bring to clinical trials. So that was a lot of information. And I wanted to end with this final thought, which is, will AI actually save us from the pandemic? And this is a thing that I'm really passionate about is no, absolutely not. That's not the way to think about AI. So the first thing is that, as I mentioned, AI has a lot of limitations. Like with the planning tools, you saw that it really relies on historical data, and with a novel pandemic, we don't really have historical data, so that's a limitation to consider. There's also a lot of ethical concerns, like with the surveillance application. Just because AI can do something doesn't mean it necessarily should, but unfortunately, in many cases, because people are working really quickly, the developers developing these systems don't necessarily always ask whether they should be doing something, and these systems end up going into the world anyway, kind of shielded by the fact that we're in a crisis. And the last thing is, a lot of the challenges that we face in resolving the pandemic are fundamentally not actually AI problems. There's social problems, there are policy problems. As someone who lives in the US right now, clearly one of the biggest challenges we have is a crisis of federal leadership, and that is not something that AI can solve. And we're really suffering from poor national coordination in manufacturing and test making capabilities, test production capabilities, and all of those things are kind of core challenges that are not going to be in AI's wheelhouse. But it is important to acknowledge that AI is a very great tool to have in our arsenal for applying to things where the problem is in its wheelhouse. And that's when I think the scientific research and the vaccine development and the drug discovery, those are all things that are squarely about finding patterns within massive quantities of data to accelerate the resolution of the pandemic. And so with that, thank you so much for listening, and I hope I wasn't too over time.
Thank you very, very much, Karen. This was a very good way to start us all off. I'm looking forward to read your reports in the MIT Tech Review. And I also recommend everybody to go to your website, karenhow.com, because there's some really, really neat visualizations on how AI work and what it can do and what it can't. And please ask questions in the chat, and we will bring them to Karen in our Q&A a little bit later. And now we're going to dig a little bit deeper into the monitoring and discovery phases of fields of how AI can be used in this pandemic. To do that, we have Björn Schuller with us from Munich. He's the professor of artificial intelligence at the Imperial College in London, and he's also the full professor and head of the share of embedded intelligence for healthcare and well-being at the Augsburg University. Please give it up for Björn. Unmute your microphone, and the screen is yours.
Yeah, hello. Thank you very much, Martin, and welcome to this part, Human-Centric AI for COVID-19. So the idea in this part is to move closer to the individual with the AI, to move partially into your everyday life and see what we can do there, which is also known as mHealth, so mobile health. So we have put together a couple of use cases where we can foresee this, and some are pretty ready to be used. You could roughly divide them into diagnoses down here, where we would actually recognize from your voice, as Karen has said, or from video or other things, that you would be diagnosed as positive on COVID-19. We have the part of monitoring, and monitoring is rather big in terms of what you can do. Karen has been showing this video of tracking of people by cameras. You could do the same by audio, for example, and other means. So you would look at social distancing, but also its effects. So we could be looking at, are people at home becoming, let's say, depressed, too alone, or whatever else. We can also monitor spread. Karen has been showing this from the data side, which is maybe not directly at the human, but of course, if you think of recognizing from the audio somebody coughing on the phone, you could then even analyze how does coughing spread over the country. And if you have something that can differentiate between COVID-19 coughs and flu coughs, you could from such means get closer to the human feedback. Monitoring of treatment and recovery is where you would be looking at, are people recovering well if they are hospitalized, for example. You could watch whether your treatment is doing a good job. And the final one here, apart from diagnosis, is information provision. So similarly to what Karen has been showing on finding in papers for scientists information, this could be something like hotlines or anything alike that gives feedback to people calling who are not experts but simply worried. So you see some things around here like stress detection, breathing rate detection, coughing detection, and so on, mask monitoring that we will be looking into more in detail now, but the idea is to monitor your behavior and your symptoms in everyday environment. So the good news in this game is that we're well prepared. I, for example, have been running 12 years of challenging the AI community to show what they can do from audio and video for many of the tasks that are relevant here. So for example, for risk assessment, is somebody at risk right now because somebody else is too close or somebody's not wearing their mask? Or for diagnosis, are you COVID-19 positive? And these use cases of monitoring, you have different, so to say, features, high-level features that you could be looking at. So for example, you could recognize with AI somebody's age and gender to see if they're on the higher risk group. You can monitor their breathing and find shortness of breathing and things like that. See and hear if their nose is congested. Find, for example, things like their health state, their lung sounds, of course, pain signs. Then you have, for example, sleepiness. Are they overly tired? All of these are symptoms of potential COVID-19 diagnosis. You can count the speakers in a room like you can count people in a video image. So a lot you can do there. And then from a sound side, we have coughing. We can localize where sounds come from to warn you, for example, if you're wearing your headphones, you don't see people in your back. We could give you a warning that somebody's too close to you. We could hear somebody sneezing. If you don't hear it, again, because you may be wearing headphones and things like that. So a lot we can do, and we're actually, AI is pretty ready to do so. Now, what you could be doing is, for example, make a histogram of symptoms. So a GP, a general practitioner, your local medic, on average has like 7 minutes for you around the world. If you're in the Northern Hemisphere, it might be above 20 minutes. If you're in some third world country, it might be less than a minute. But your AI could be with you and to see, and you know maybe these kinds of charts from magazines and newspapers, whether you're rather COVID-19 or having a flu or a cold. What is really informative here is the histogram. So which of these symptoms are more or less present? And what is their onset over time? For flu, it's usually very short. For COVID-19, it's rather lengthy. So you have, as an AI, the opportunity to be with that person and get much more information than any GP would have to collect this kind of info. Now, what we have been starting to do in this sense is collect speech data, for example, from COVID-19 patients with our colleagues in Wuhan, China, and our colleagues here in Germany. So we're collecting data from such being tested positively and such being tested negatively. For example, saying a certain phrase like, I agree to use my voice for coronavirus-related research purposes. And then with some AI and machine learning, we can get an automated severity indication and a diagnosis. Diagnosis is binary, so thumbs up, thumbs down, you're having COVID-19 or not. This is a shockingly high number for only listening to the voice. We have an 81% correct rate at this moment when 50% is chance level. But of course, these results always have to be taken with a grain of salt, how well this would generalize across countries, acoustic conditions, and whatnots. So this is on the data we collected in the hospitals. Subject independent, listening to the voice. Now, three-way severity is meaning that we have indications of how severely is your stage of COVID-19. This is a three-way problem, meaning that chance level would be a third or 33% roughly, and we're at 68%. This is encouraging, meaning that you could have an early diagnosis and good feedback already from AI around you. We also looked into other phenomena more related to your well-being. So for example, patients hospitalized sleep quality, COVID-19 patients, their fatigue and their anxiety. This is just the histogram of what we collected for 3 levels each. And you can see for fatigue and anxiety, we have people mostly around the middle, but some cases of higher increased anxiety or increased fatigue. And for sleep quality, it's not even balanced at all. So the idea is, again, we are just listening to your voice when you're speaking, and you can see these problems are partially more challenging than the three-way severity or the diagnosis. So for fatigue and anxiety, we're dropping a little bit here in accuracy, but all of these things can be targeted. Now that sounds good. Maybe you can monitor, you can diagnose, but there's of course a lot of challenges. Now, Karen has been revolving around this topic that you can't overstress: ethics, legal and societal impact. So is everything we can do with AI also what we should do? And I will not have time for going into those considerations. But just to name a few other ones, time is very pressuring at the moment. We need to be as fast as never before in providing solutions. Then we need to collect data from patients to make sure we can learn our AI and machine learning systems from real-world occurrences. And for that, I would like to talk about model sharing. So giving your information rather than donating your blood, donate your data such that AI can be better trained. Maybe not rather than donate your blood, but in addition. Real-world processing, meaning simply if you want to diagnose your health state in the wild, we should be robust against disturbances from whatever, bad camera, bad audio, whatever disturbed signal. Green processing means we should be very efficient. We have to be data efficient with very little data. We have to make good decisions. We have to be memory efficient. We don't have a lot of computational power on your body-worn devices like a smartphone maybe, but even if you do big number crunching, we always need to be efficient. Many white boxes indicate that there's a lot more, but of course what is very important also is trustability of results. Now in the remaining time, I just want to give you some insight on these things. Donate data is the first. This is our app where we collect, pardon the German here, your audio. So you do a user profile and then you decide how long you want to track your audio. This is usually done when people are entering the hospital. They take around 3 hours there. So they get this device in Augsburg at the moment being, and they decide to be recorded for 3 hours, but you could also do it overnight when you're sleeping. And then we would get a histogram like how much did you cough, how much did you not cough or sneeze or whatever other symptom that we're looking for. Now the interesting part is here at the end, you're being asked to donate data. The AI would pick those samples that it believes are most informative to improve its knowledge for you to choose from. So maybe it guides you through 6 examples after 6 hours and asks you, after playing it back to you, will you donate this, yes or no? So the whole idea of donating data. Now, with this kind of help, we have been able to improve constantly our recognition performance and can recognize symptoms even in the wild at 83% correct this moment being. 83 might not be enough, so you want to do more sharing. And luckily, federated machine learning has the answer where you don't give away your personal data, like your images or your audio or something like that, but rather than that, just model updates. So you do not share your images here, but only how your AI changed its parameters. After some local training on your device, this would be averaged. So the other users in the world would not get your images. They would not even get your parameters, but just averages over parameter changes, and then the model would improve for everybody. Now, what about privacy? I don't have the time to go into detail here, but over the 12 years I've been mentioning, we have been finding a lot of other things in the voice, like are you sincere or not? What is your native language? Do you have Parkinson's? And many other things. And if you share your audio and if you have something that can analyze your voice for COVID-19, you want to be sure that it's not depicting other things like you're lying at the moment being, or you're on Parkinson's or whatever. Green means we have to be efficient, so we need to reduce the size. For our application that I just showed, we were able to reduce from 230-ish megabytes down to 12 with some AI pruning. That means we cut parts of a neural network away. We use simpler number formats, not float or something, but just integer numbers, and we are able to have similar performance if we do this smartly. And of course, there's a lot more to green AI. Now, coming back to privacy, you want to be protected, and at the moment being, sorry for this. And if you do happen to find that Easter egg, we'll have to cut this off and go back. There is something known as adversarial attacks. So if you're speaking, for example, in an angry voice, an AI can attack and add some noise which is not perceptible to humans, and another AI would not recognize angry any longer, but happiness. Same here, of course, you could have a COVID-19 negative diagnosis, but somebody attacking you would be adding some noise not audible to humans, and at the border when you want to cross, the system would say you're COVID-19 positive, you can't cross the border. So we have to make sure that we protect you also against hackers, sort of, that hack our AIs. Now, trustable, I said, is the most important one, of course. If you think of the first robot or humanoid in history, the Talos, the bronze automaton, was considered as quite evil, as a killing machine. We, of course, want much more of such a big Hero 6 perception, where your inflatable health robot is your best friend. So we have to make all efforts to be sure that the AI is trustable and, well, perceived, usable, and really used in the end. So the major challenge otherwise is that this is a highly multidisciplinary field. This is just a survey we did on what fields are involved in COVID-19 literature, which of course right about now is rapidly growing. This is just looking at child literature on COVID-19, but you could see it's highly interdisciplinary. So what matters a lot, of course, is that yes, AI is not the solution, but it holds a lot of promise, and in particular, if we all work together with the experts from other fields. Now, by that, my 10 minutes come to an end too. I would like you a lot for your time and your interest. To thank you, sorry. I would like to thank the people behind what I have been showing, and would end with the words AI for COVID-19 should be human-centered, and it should be available for all, anywhere and anytime. Thank you very much.
Thank you very much, Björn. And I'm both feeling optimistic and a little scared right now, but I guess that's what AI gives you. Please keep the conversation and share questions in the chat. We're now gonna go to our third and final speaker today. His name is Raul Panicker. He's calling in from Mumbai, India. And he has a long background in working to utilize AI for social good. He's currently the Chief Research and Innovation Officer at Wadwani AI. And he's working on a project financed by the Bill and Melinda Gates Foundation called Cough Against COVID. And so he's going to go a little bit deeper into what Björn, some of the stuff that Björn just talked about, but he's also going to talk about how we can actually, and the difficulties of implementing technology into society and with human beings. So please welcome Raul Panicker. The screen and microphone is yours.
Thank you, Martin. So let me get my slide going. All right, is everyone able to see that? Yeah, okay. Yeah, so this is where we were in 2020, in March 2020. the pandemic was beginning around us, it was getting real. And we are a non-profit AI research institute with the sole mission of AI for social good. Our goal is to use AI to help the underserved billions in the world, especially in the developing world. And so we said, hey, we can't be continuing with our regular work. We have to do something here. What can we do as an AI institute? And till then, I'll give you a flavor of the sort of things we were doing. We were working to help cotton farmers identify pest attacks early. We were working to have weigh babies using just a smartphone, where a healthcare worker can take a short video of the baby, and we could detect low birth weight and premature babies from this so that they could get care. And we were working to help tuberculosis patients, right? Large scale problems we were on, and we were staying quite busy with this. Stuff started happening, and we looked at what we can do. Broadly, we decided this, you know what, with the things with the capabilities we have and the support we have and the need out there, there's two areas we decided to focus on. One was some mechanism by which we could screen a large number of people, because we knew that most of the world, there would not be adequate testing capacity. You cannot possibly test for COVID everyone who has a fever and cough. And so what can we do there? And the second thing we started doing was, how can we help the public health world target their efforts by planning interventions, predicting healthcare demand, and so on. So I'll tell you a little bit about those things that we're doing. But the main thing I'll try and do in this talk is to use those as examples to share some lessons that we've learned in this process, lessons learned from our past work, as well as working in crisis mode currently. So Bjorn mentioned our work in creating a cough-based screening tool. The goal here is simply this. Like I said, if we look for highly symptomatic patients with advanced symptoms, by then it's too late because they've already infected a whole bunch of people. Can we, if we try and screen everyone, test everyone with a fever and cough, we'll have to test way too many people. Right? So what can we do to provide in any given city? So for example, I'm in Mumbai city. If Mumbai has the capacity to test, I don't know, 10 or 20,000 people a day, who are the top 10,000 people I should be testing who actually approach the healthcare system, right? Potentially with some of these symptoms. And as Bjorn shared, there's useful signal in voice, and especially in the cough signal, because, and this is anecdotally known regarding COVID, and it is also known from other diseases that people have tried to diagnose from voice and cough. So we have a few arms of work going on here. This is, by the way, and we said we should do this in an open fashion. We should form a global coalition, and we should, so we are funded by and supported by the Bill and, so it's not just funding, the Bill and Melinda Gates is an active foundation, is an active supporter. So beyond funding, we also have access to all their networks. So for potential deployment, we're looking at if this works out, we can deploy through partners globally. And we have a collaboration with Stanford University as well, with Professor James Zhao and group. And we said, the way we should do this is, as we collect data, we should eventually make this open access so that other people can use the data sets and build on the solutions. We have a few ways to actually, now how do we quickly collect this data? We started doing this multiple ways. One is there's a large crowdsourcing effort in progress. It's called Cough Against COVID. If you go to that site, please spread the word. Like Bjorn said, you can do citizen science and donate your cough. And this will be anonymized and made publicly accessible and used to actually build this tool. We currently have submissions from over 25 countries across the world, right? And that's growing day by day. In addition, we are collecting data from facilities, testing facilities. We have data from testing. We have data from quarantine facilities that we're collecting. and we have data from home isolation. And all of this is being done with the necessary approvals, both the IRB approvals as well as the approvals from the authorities. With the goal being use cough, and I'm simplifying it by saying cough. There's also voice signature that we're collecting, along with other information like symptoms and course location, even at a zip code or a pin code level, okay? Because that gives you useful information about prevalence. And combining all of those to actually make a recommendation and then saying, well, is this person at high risk and therefore should be tested, or seems sufficiently low risk? It's a screening tool where we don't think that this will be sufficiently accurate to be a diagnostic tool, as we trade off our sensitivity and specificity. We now have, we are in the process of building our models, and we have a few thousand cough sounds from many patients here, and also lots of non-COVID patients as well, because we need the negative class as well. The second thing, a second set of things that we're doing is, and this is largely India focused, we are working with, so we realize that a lot of the work is on the ground level is not happening at a central government level, but at state and city administrations. So we've engaged with them and we are providing them support. So for example, projecting for them, how many ICU beds will they need 2 weeks from now or a month from now? And that's been hugely useful for cities so that they can actually start planning for resourcing. Right? Scenario modeling, which is what ifs. Oh, if I change the policy in this district or in this ward to a severe lockdown, I go from a severe lockdown to an ease lockdown, what should I expect? What's the spike I should expect? Right? Asking the what if questions. And so, and again, this is also being done through a coalition. There's many streams of work. You'll see many parts here. It needs many parties to work. It's not just government partners. It needs technologists. It needs public health experts, medical experts, and so on. So some lessons learned in this process that I would like to share. Sorry. Yeah. I think this is basically where I like to focus, which is doing something like this. It takes a village. I don't. Some of you may be familiar with the phrase "takes a village," and so there's people out there, and I think all of us may be familiar with various efforts of technologists trying to solve the problem with very little context and believing in techno-utopia, right? I mean, and in some ways, this is what Karen was referring to. But really, you need public health, you need medicine, you need field operations, you need regulatory. So many different skills are needed to actually make real solutions that work in the world. And I'm happy to take more questions in this regard. In a crisis situation, you know what, the problem changes. Initially, the problem was, oh, how do we do containment? But once the disease starts spreading, it's about how do we actually provide enough treatment as opposed to doing containment. There's many things that change. Problem changes for multiple reasons. There's changing priorities for the stakeholders involved. So for example, in our scenario modeling and intervention work, it's the state authorities or the city administrators. Their priorities change over time. Capabilities change over time, right? Initially, everyone's scrambling. After that, some early capabilities set up, and then there are new challenges. Okay, so for example, some data flows start, and then the challenge is no longer necessarily ensuring data flow, but how do we handle this large number of patients? How do we move from strict lockdown to how do we do a control release, okay, without things getting out of hand? And also our knowledge of the problem changes, right? Now we know, for example, that 60 to 80% of people around who are COVID positive are asymptomatic. That affects our cough solution, for example, right? Because the screening, it may not be, if we just look for people who have fever and cough and actually ask them to be screened, that still misses all the asymptomatic people. Right? We also now have knowledge about what percentage will be severe cases and so on, and what possible complications are. I'd say also, this is true of most AI solutions, and in fact, most technological solutions. Be certain that you will not be able to predict the ways in which technology gets applied out there, right? And so it is critical that you have post-deployment monitoring, right? It's not, you cannot take this approach of, oh, I created a solution, now let's throw it over the wall and give it out in the real world. For example, a cough-based solution, if we were to make a screwy solution, will either cause a lot of panic and deluge the healthcare system or miss a lot of cases, right? As an example. I can give you other examples. We, in our projection models, we built good models and did very controlled deployment with a few cities. And then after a while, because we kept monitoring it, we realized some cities we were getting very abnormal predictions. And we realized what was going on. Some of these models are only as good as the data being fed in there. And you know what, on some days, the city administrators are very busy. And so they wait and then enter all the cases tested till then in one bunch on the third day. In the data, it shows up as a sharp spike. And of course, all your projections go haywire. But in reality, all they did was, okay, they were busy with other things and waited to enter the data. Right? So it's very, very important to actually never forget the people. There's real people that we're trying to help, right? They always keep them front and center. And so there is always a tendency in a crisis situation that things like ethics can be circumvented. And there are efforts out, examples of that you'll see out there. I don't subscribe to that. The Institute doesn't subscribe to that. I don't think any innovator should subscribe to that. Any of us should subscribe. I'm not of the school of thought. To me, the ends don't justify the means. Right? The means are as important as the ends. I'm an old school follower of Mahatma Gandhi, so, for whom the means was as important as the ends. And so, these are the people we are trying to help, and we never try to forget that. These are migrant workers, millions of them who, after lockdown, because of suspension of services, are walking hundreds or even thousands of kilometers in the hot sun on freeways to get home to their villages. Right? And there's hundreds of millions of poor across the developing world. In fact, not hundreds of millions, there's billions across the developing world who desperately need technological solutions because, you know what, high-end solutions will never reach them. They're the ones that we are trying to help. So with that, I'll wrap up. Thank you.
Thank you. Thank you very much, Raul, for sharing some super important perspectives. I know that it's 6 p.m. and that we're scheduled to finish now. I ask for 15 more minutes for those of you who want to stay along for a Q&A. If you really need to leave, totally understand. There will be a lesson on AI and different perspectives of AI each Wednesday. So please look at our site and our social medias and join that if you need to go now. But I would like to hand it over to Jeanette, who will ask a couple of persons in the audience. And I suggest we do 3 questions before we wrap up and enjoy the rest of our days and evenings.
So first of all, there was a comment about privacy from Ashfaq. I hope I pronounced it right. But maybe you want to speak?
Yeah, just hello everybody. I just wanted to communicate or convey, this is just a comment, and the idea here is that we are kind of struggling with data privacy issues, and to me the challenge of how much of data and AI, because data is critical for AI, and how data privacy is maybe possibly killing. I just wanted to have some comments from representatives how data privacy is killing artificial intelligence.
Does anyone want to say something directly? Björn, Raul, Karen?
Yeah, well, I mean, privacy is a big issue, definitely, and data protection is a big one. Usually we're trying to circumvent this also from the technical end by having your data not leave you. So trying to have it on your smartphone and not go to a server or something like this. And try to develop mechanisms like the one I showed where we, if we need to share information for everyone's good, try to have as little information as possible leave your personal device. And then, of course, there is the aspect that I have been also alluding to, that people could hack AI for evil purposes. So there's quite some new dangers maybe in this respect coming up. So the important step here is always to be au courant or to be on level with anything that could threaten data privacy. But obviously that's a major concern and a major race to be won, that data really is safe.
Thank you. And I have another question from Marco Weber regarding asymptomatic causes. Marco, do you want to unmute yourself? So maybe he's already gone. Then we had a lot of comments from Andrea Kronenthaler. Maybe you can choose one question for one of the speakers.
So if I have to choose, I would like to ask Rahulji about the social, about the social. Can you hear me?
Yes, I can hear you. I was just saying you can call me Rahul. I haven't earned the respectful G part.
You have, for sure. What I like to ask is, there are always these tendencies in crisis that somebody is the bad guy. I mean, at the beginning I was in India and all the white people are the COVID people. And now the Muslim society is are the COVID society. So how do you deal in your research about this? And in the model creation, you know, it's a big effect. So I'm a sociologist. I am coming from the other side. Thank you.
I'm going to answer it at two levels, and I'll avoid trying to give a glib answer. Okay. Every society has its bigots. Okay. And there are, especially in a crisis, there's many people who live in fear. And there are people who are interested in exploiting that fear for their gain. That's the unfortunate reality that we see. As for what can we do? I can give a few. I can give a few sort of angles of answer, but I think for given that the session's about AI, one thing I would address is about AI bias. Because algorithms learn from the data, and if the data has the bias of people, that bias will show up in algorithms. So for example, if certain communities are getting preferentially are underrepresented, then the algorithm won't learn enough typically about how to perform well in those communities. It might be gender, right? It might be, for example, how well it works among people who smoke or chew tobacco, which is strongly correlated with socioeconomic status. Right? So it can show up in unexpected ways. And so when we collect our data, we also collect a lot of contextual data about age, gender. There is personal information that we collect for this reason, and we do not make that public, of course. We have strict protocols to prevent that. But we collect that data, and if you have that, using that, you can there are algorithms, there are technical ways by which you can unbias algorithms, or you can test for bias. My utopian hope, in some ways, is that through debiased algorithms of this, I shouldn't say unbiased, debiased algorithms of this sort, maybe we can provide fairer tests than what society as a whole may be doing.
Thank you, Rahul. I think we have time for one more question or comment, and maybe Alistair Alexander, you want to contribute your question. Or your
hi, Jeanette. Yeah, I was just very struck listening to it. I really loved all those talks. But I guess the core issue for all of us is how do we manage societies? How do we function as normally as possible in a time when we don't have a vaccine? And it seems, going back on that and looking at the experience of Asian countries, which is obviously vastly superior in terms of their record on this to other countries, that it's really about tracking and tracing. And the real successes have been in human teams of trackers and tracers. It's not been in apps. And I'm just wondering, in that context, really, in terms of controlling the virus before a vaccine arrives, does AI and indeed technology have a role to play there, or is it really a human problem with a human solution?
I can address this one. Yeah, I think related to what I mentioned in my presentation already, I do strongly believe that AI is not the right tool for many of the core challenges that need to be solved with a pandemic. And I think you're right in that contact tracing has been the demonstrated way to really get contain a virus quickly in the early stages. And as much hype as there is around automated digital contact tracing tools, really the winners are the manual contact tracing teams, that like hundreds of thousands of people that are going out, conducting interviews, build trusting relationships with people so that they can get the right information about which infected patients came in contact with whom. And so I don't think that fundamentally, if we're talking about early stages of a crisis like this, that AI actually has that big of a role to play. But I do think that once we get to a point where the crisis has already gone out of hand, that's when AI starts to become more palatable and starts to be more useful in helping with things like scientific research, drug discovery, vaccine development, things that we actually need because we failed to contain something early on.
If I may add something, in general, the perspective I like to take is technology is an amplifier. It's an amplifier of human intent, right? When we discovered fire, we could cook food and defend ourselves against wild animals and create light, but we could also set fire to the neighboring village. And in similar way, AI can be used in many ways, or any technology can be used in many ways. The application is driven by human intent. And in this case, the way to look at technology is, what are the things that I want to do in society that is beneficial, and how can I amplify that with the right technological tools? And sometimes, you know what, technology, there is brick and mortar stuff that needs to be done that is not about digital technologies at all.
So thank you, Rahul. Are there any pressing questions or comments you want to contribute? Otherwise,
I'd like to say one thing. This was my question for Björn from Germany. I am still busy, but I have still some more lectures, coach lessons about the topic of trust. What will happen with all this data? Okay.
Yeah, so trust is, of course, a major issue. Before COVID-19, we have been trying to get mobile health data from people with depression, multiple sclerosis, and other health states. The adherence to technology was at 7%, so very, very low, making trust and usability really a major concern, because all of the good AI is good for nothing if people don't use it. In order to have trust, of course, it needs to work. You wouldn't use something that is not giving you any real benefit. So if it makes a lot of false alerts, you wouldn't use it. And of course, it has to be safe and protected and everything. But then at the end of the day, it's really a very high goal, if not the highest goal, that we have AI that can be trusted. And as Raul put it, trust, of course, also comes from the people behind. How is it going to be used? Because if it's being used in the wrong way, trust will diminish, not maybe so much because of AI's lack in capability, but simply because people are frightened. And we're living in times of fake news and conspiracy theories, so we have a even harder task to create trust in AI.
So we developed in Europe, it was a European project, a healthcare robot to care about elderly people. So this subject with trust, it was such big, and I think with AI it is much more pressure. So good luck and thank you.
Yeah, thank you. Just to mention, speaking of robots, AI is in many, many places that we also haven't talked about today and where it might be quite useful. For example, robots, if we can't be close to each other, maybe robots can do those tasks. And speaking of elderly, we have been using AI in caretaking facilities. There's quite an interesting effect that you sometimes have people who don't trust, but you also have people that really miss the AI once it's gone because the test is over. So there is a chance that people really love AI. We just have to do it right.
So maybe that's a good last word. I don't know if you want to add something, Martin. Otherwise, I would like to draw your attention to the upcoming couch lessons. So we have a lot of lessons that will come. One especially about the human-robots interaction, and the next lesson will be about AI and intelligence. Therefore, we have invited one philosopher, Markus Gabriel from Germany, and one machine learning researcher, Nell Watson from the United States, and they will discuss about the status quo of the artificial intelligence right now, and they also want to discuss about the question, what does intelligence mean actually? So we hope to see you again. We hope that you spread about our lesson, that you will share the content through your social media channels, that you will also tell your friends about our couch lessons. If you need more detailed infos, you see the website. You can go on this website and you can sign up, and we hope to see you again. And maybe Martin, you also want to say some last words.
Just want to say goodbye, take care, wash your hands, keep distance, and all of the rest. And I hope to see you all in Meet Space in 2021 or so.
Thanks to everyone, especially to
Raul,
to Karen, and to Björn.